right, so now I'm going to do example 3 for you. And don't be confused here about degrees and radians. So this value A is being measured in degrees Celsius because it's a temperature. But our cosine function here, we're measuring in radians because there's nothing talking about degrees here. And the pi over 12 is a clue that I'm talking about radians. So T is measured in hours. So my unit for T is hours. My final unit for A, though, is degrees Celsius. So I can think degrees Celsius, hours over here, and I have two different functions. So I have this function for temperature inside the house, and then I have this function for temperature outside the house. So find the temperature inside the house at 8 a.m. Well, we're starting our time at 4 a.m., so 8 a.m. is going to be when T equals 4. I want the temperature inside the house, so I'm using my A function. So A is going to be equal to 23 minus 3 cos. If T is 4, then I'm going to get 4 pi over 12, which is pi over 3. Pi over 3 is my tall angle. Cosine is my adjacent side, so it's going to be short, so that's going to be a half. So A is going to be 23 minus 3 times a half, so 23 minus 1.5, which will be 21.5 degrees Celsius. Write down an expression for D equals A minus B. So I want the difference between inside and outside temperature. So my difference is going to be 23 minus 3 cos pi T over 12 minus this function. So 23 minus 22 is going to be 1. Negative 3 cos pi T over 12 minus negative 5. So that's going to be plus 2 cosine pi T over 12. Notice I could only add these two functions because they had the same argument. If they didn't, I would have had to have minus 3 cos whatever this is minus negative. So then it would have been plus 5 cos whatever that was. But because they're the same, they're like terms. All right, so now I'm going to sketch my graph for the difference. So here, my center value, my D value is going to be 1. So I'm going to call this my 1 and think about that as my center. My amplitude is 2, so I'll go up 2. So there will be my maximum difference, which will be 3 degrees Celsius. And then my minimum difference, I'll go down 2, so I'll be at negative 1. All right. So if I'm going to graph this, cosine starts at its top. Well, 1 period is going to be 2 pi divided by my pi over 12. So 1 period is going to be 24 hours, which is where I wanted to graph the whole thing. So I could do it the way I wanted. I should have started that way. So I'm actually going to take all this out. All right, so middle, bottom, middle, top. All right, so this is going to be my 24 hours. Half a period is going to be 12 hours. So that'll be 6, and this will be 15. All right, so sketching my graph still, max, middle, min, middle, max. So there's my 24-hour cycle. I can see that at the beginning at 4 a.m., so remember we said time 0 was 4 a.m., so this is going to be at 4 a.m. again. So at 4 a.m., the difference between the outside temperature and the inside temperature, so I've got that outside minus inside, was positive 3 degrees. So it's 3 degrees warmer in the house than it is outside the house. Just to think about what's happening here. Determine when the inside temperature is less than the outside temperature. Well, that means that A minus B is going to be negative. So that's this region here. So during these times is when it's colder inside the house than it is outside the house. So For my Japanese house, this is not what this graph looks like. In my Japanese house, maybe I have this little bit of time where it's warmer inside my house than it is outside. Maybe not today with it being snowing, but pretty close. But for this graph, I'm looking between these two times. So I can solve this equation. So let's see what happens if I solve it just by hand. So I want to know these points where the temperature is equal inside and outside the house. So that means my D is going to be 0. So if I set this equation equal to 0, I'm going to get 1 plus 2 cos pi t over 12 equals 0. So if I rearrange that, I'll get cosine of pi t over 12 is equal to negative a half. Well, this is something that I know, or I should know. I should know the angles when cosine is negative a half. That's going to be my tall angles in quadrants 3 and 4. So I'm thinking about my unit circle. So I'm thinking about quadrants 3 and 4. Sorry, not 3 and 4. I'm thinking about quadrants 2 and 3 because that's where cosine is negative. I want it to be negative a half. So I'm thinking of my tall angles. So this first angle would be 2 pi over 3. This one's going to be 4 pi over 3. So I need pi t over 12 to equal 2 pi over 3 or 4 pi over 3. Well, if I rearrange that, then I'm going to end up with t being equal to, let's see, my pi is going to cancel. That's going to be 8. Or, again, when I cancel, I'm going to get 16, which makes sense looking, oh no, the 16 does not make sense looking at my graph. So if I multiplied by 12, that is 4 pi over 3. 6, 12. It looks like it should be something like, oh, this is 18, not 15. All right, so 16 does make sense. So it's 8 hours from 4 a.m. or 16 hours from 4 a.m. So that's going to be between noon and, if I add 16 and 4, then I get 20, and that's going to be 8 p.m. All right. So that's when the temperature inside is less than the temperature outside.